Welcome to the complete tutorial video for the Iconic 5 Virtual Drum Synthesizer for Kontakt. If you want to jump ahead to a particular topic, scroll down and expand the description of this video, and you'll see a hyperlinked table of contents. Just click on the blue hyperlinked minute and second marker next to the topic you want to learn about, and the video will jump ahead to that chapter. The Iconic 5 is made for use with Native Instruments Kontakt 6.6 or higher, and it's also licensed to unlock the free Kontakt Player 6.6 or higher without limitations. So if you don't own Kontakt, you can still install and use the Iconic 5. The Iconic 5 uses Native Access download and installation tool for fast and easy installation on your Mac or PC. Go to the link below in the description of this video to go directly to the Native Instruments site to download Native Access. Once you have it downloaded and installed, you'll be prompted to sign in using the email and password you used to set up your Native Instruments account. Once you have Native Access running and you're logged in, click the Add a Serial button in the upper left-hand corner. Enter your Iconic 5 serial number in the dialog box. If you purchased directly from the Iconic Instruments website, your serial number would have been visible in your browser after purchase, and you also should have received a follow-up email directly after purchase from Iconic Instruments Checkout that contains your serial number. If you didn't see that email, check your spam folder or contact us and we'll resend it to you. Once you have the serial handy, enter it into the dialog box in Native Access, and Native Access will now authorize your machine for the Iconic 5. At this point, you'll see the Iconic 5 in your Not Installed tab. Just hit the Install button below the Iconic 5 graphic, and Native Access will download and install it on your machine. Once that's completed, you'll see the Iconic 5 in your Installed Products page, and you're ready to start using the Iconic 5. The first step to loading the Iconic 5 is to load Kontakt. Kontakt can be loaded in standalone mode or as a plug-in instrument in your DAW. Whether you're using Logic, Pro Tools, Ableton, Reaper, etc., whatever digital audio workstation or DAW you use, the process is fairly similar. You first want to open an instrument track in a session. You'll want to find the plug-in loading button in the track, usually above the fader in your DAW's mix view, or it can be somewhere near the track label in your track view. Once you click the plug-in loading button, look for Native Instruments from the list. Choose Kontakt, and then select one of the setups for Kontakt in the list. You'll probably want to select stereo, or if you plan to use the Iconic 5's output busing matrix to route the drum and cymbal channels to individual tracks in your DAW, you'll want to select a multi-output option. In that case, I recommend selecting the multi-output 16 times stereo option. Once Kontakt is loaded, you can now open the Iconic 5 within the Kontakt window. There are a few ways you can do this. You can click on the Files menu, represented by the disk icon, select Load from the pull-down menu and navigate to where you have the NKI or instrument file located on your drive. You can also use the browser to load the Iconic 5. Click the Workspace menu and select Browser. On the left, you can either select the Files tab to navigate to the Iconic 5, or you can select the Libraries tab to reveal your installed libraries, and the Iconic 5 should be visible. If not, click the Manage Libraries button and make sure the Iconic 5 radio button is checked. If the Iconic 5 doesn't appear in the list, hit the Launch Native Access button to make sure it's loaded on your computer and not just sitting in the Not Installed tab. Refer to the previous section of this video for complete installation instructions. And finally, you can use the Quick Load function. To open the Quick Load menu, you can either go to the Workspace menu and select Quick Load, or if you right-click in the empty space below your instrument, it will automatically bring up the Quick Load menu. The easiest way to load the Iconic 5 into the Quick Load menu is to use the Files tab in the browser to locate the Iconic 5, and then with the Instrument tab on the Quick Load menu selected, just drag the NKI file into the left column. This way, whenever you open Quick Load, the Iconic 5 will be there in the Quick Loader's Instrument tab. The Iconic 5 is NKS-ready and fully integrated with your Native Instruments Machina and Complete Control Studio Controller keyboards. Native Instruments has done a comprehensive video on how to navigate NKS in your productions. Click the link below in the description of this video to view the Native Instruments tutorial on NKS. But here we'll just give you a basic overview to help you get the Iconic 5 up and running with your NKS system. NKS, or Native Control Standard, is specific to the Native Instruments Complete Control and Machina hardware controllers. You first want to make sure you have the Complete Control or Machina software downloaded and installed on your computer. Each different model of Machina will have its own specific software, so you should look on the Native Instruments site for your unit's download section to find the software specific to your model of Machina. Currently, the Complete Control software is part of a package called Complete Start on the Native Instruments site. So if you're a Complete Control user, look for the Complete Start download. For either the Machina or Complete Control software, you'll be prompted to log into your Native Access account to add the software to your account. Then, when you open Native Access on your computer, the Complete Control or the Machina app will appear in your Not Installed tab. The process is the same as the installation for the Iconic 5 in the previous section of this video. Simply click on the Install button below the Complete Control or Machina icon in the Not Installed tab, and Native Access will download and install it on your computer. At this point, you'll see the Complete Control or Machina software appear in your Installed Products tab. Now you're ready to start using NKS. I'm using the Complete Control software for this video, but the process is the same for Machina. You can open Complete Control as a standalone app or as a plugin within your DAW. For use as a standalone app, find the Complete Control or Machina app in your Applications folder or wherever you have it installed on your Mac or PC. Make sure your Complete Control or Machina hardware is plugged into your computer via USB cable and make sure it's turned on. Then open the software. Click the arrow next to where it says All Instruments and you will see a list of your installed NKS-ready instruments. Single click on the Iconic 5 icon and a list of snapshots will appear. If you single click on any of the snapshots, or if you scroll through them, you'll hear a short preview of what the settings of each preset sounds like. Double click on the one you want to use and it will open. You'll notice when you open the Iconic 5 that the keys on your Complete Control will change color to match the mapped keys on the Iconic 5. If you want to switch to a different preset, you can double click on a different snapshot, or with the Iconic 5, you can simply use the built-in preset loader to switch between presets on the screen. The process for loading the Complete Control or the Machina app in your DAW as a plugin is very similar to the process for loading Kontakt itself as a plugin in your DAW, which we went over in a previous section of this video. With an instrument track open in your DAW, click the Plugin Loading button in your track. Find Native Instruments from the menu and select Complete Control or Machina from the list. You can select the stereo option, or if you want to use the Iconic 5's output busing matrix to print individual drum and cymbal tracks in your DAW, you'll want to select the multi-output 16 times stereo option. We'll go over the output busing matrix and the process for printing stems in your DAW in a later section of this video. You can open the Iconic 5 in the exact same way as we just demonstrated in standalone mode. Whether you're in standalone mode or in plugin mode, there are a few controls that are worth going over. Along the top, there are 4 buttons. Hitting the plus sign opens up the standard Kontakt controls across the top of the Iconic 5. The plugin button opens a bar where you can add other third-party effects if you want. The knob button opens up the pre-assigned hardware knob controls for the Iconic 5. You can either rotate a hardware knob and that parameter will be reflected in the app, or you can move the virtual knobs directly on the screen and the hardware will reflect those changes. These 8 knobs control these 8 parameters in the selected drum or cymbal module in the Iconic 5. And if you want to switch to a different module, just select a different module along the top and the hardware knobs will now correspond to that Iconic 5 module. You can trigger the Iconic 5 using an external MIDI keyboard or pad, using MIDI from within your DAW, or using your mouse to click Kontakt's virtual keyboard, which you can access by selecting Keyboard from the Workspace menu. The bass module is triggered by note C1, labeled in red. The snare module is triggered by note D1, labeled in yellow. Toms 1, 2, and 3 are triggered by notes G1, A1, and B1 respectively, and they are all labeled in light blue. The 3 hi-hat permutations, closed hat, pedal hat, and open hat, are triggered by notes F#1, G#1, and A#1 respectively, and they are all labeled in green. Cymbal 1 and Cymbal 1 dedicated bell permutations are triggered by notes C#2 and D#2 respectively, and they are labeled in purple. And finally, Cymbal 2 and Cymbal 2 dedicated bell permutations are triggered by notes A2 and B2 respectively, and they are also both labeled in purple. We've added a normaling feature for all knobs and faders in the Iconic 5. To make any knob or fader jump to its default value in the Iconic 5, just Command-click the knob or fader on a Mac, or Control-click the knob or fader on a PC. We've also added a ganging feature for controls on the toms and cymbal modules. So if you want to move any knob or fader simultaneously in toms 1 through 3, or cymbals 1 and 2, with the exception of the tone or tuning knob, you can Option-click on a Mac or Alt-click on a PC while moving that knob or fader. And if you want to gang normal any parameter in the toms or cymbals, with the exception of tone, you can Option-Command-click the parameter on a Mac or Alt-Control-click the parameter on a PC. Contact gives you the ability to make any knob, fader, or button subject to MIDI CC or control change. This just means that you can control any parameter with a compatible MIDI controller, giving you tactile MIDI control with your hardware. To assign MIDI CC to a parameter, simply right-click the knob, fader, or button, select Learn MIDI CC Automation, and start moving the hardware knob, fader, or button you want to use to control that parameter. Moving the hardware will now control the software. If you decide you want to remove that assignment, right-click the parameter on the screen and select Remove MIDI Automation. There are 2 panels in the Iconic 5, the Instrument panel and the Mixer panel, and you can toggle between them using the bottom tabs. The Instrument panel contains the main synthesizer controls and some basic mixing controls that correspond to the same controls on the Mixing panel. There are 5 drum modules, 1 bass, 1 snare, 3 toms, 1 hi-hat, and 2 cymbal modules. The far right module contains the target mode button, presets controls, delay time and return level, and reverb type and return level. All 5 drum modules are almost exactly the same, except that the bass and snare bend range is somewhat less than the toms, the snare module has a different noise section from the bass and toms, and the snare has an added set screw to control the amount of frequency modulation, which we'll cover last. Each drum module's sound is made of some balance of 3 constituent sounds: click, which is essentially a short burst of noise, noise, and tone. The bottom right click drum knob sets the balance of click and drum sounds. The drum sound is comprised of a balance of noise and tone, which is set by the noise tone knob directly above. So if you want pure click, you have to turn the click drum knob all the way to click, and then the noise tone knob becomes irrelevant. If you want pure noise, the click drum knob has to be turned to drum, and the noise tone knob has to be set to noise. If you want pure tone, the click drum also has to be set to drum, and the noise tone knob has to be set to tone. So these 2 knobs are used to set your balance of click, noise, and tone for each drum module. The click and noise components are especially affected by the top right noise knob, and a portion of the tone component is also affected, but we'll talk about that afterward. This knob sets the cutoff frequency of the low-pass filter on everything relating to the noise component of the sound. Since the click sound is simply a short burst of noise, it too is subject to the low-pass filter. So when you have it set to pure click, the noise knob affects the color of the click sound. The cutoff of the low-pass filter actually moves as the note decays, giving the noise component of each note a filter sweep effect. And the velocity, or how hard you hit the note, actually has an additional impact on the starting point of the cutoff. Softer notes start at a cutoff frequency closer to what is set by the noise knob, and the sweep amount is minimal. Whereas harder or higher velocity hits push the cutoff to a higher frequency and increase the amount of filter sweep. Another way to think of how this works is that no matter how hard you hit the note, the cutoff always ends its sweep at the cutoff frequency set by the noise knob. Lower velocity hits, in addition to playing back at a lower volume, don't push the starting cutoff as far up from the cutoff set by the noise knob, so the journey of the filter sweep isn't as great. Higher velocity hits push the starting cutoff higher, and the cutoff rebounds to the cutoff set by the noise knob. The result is a very lively and dynamic touch-sensitive noise sound. Our resonance set screw gives you control over the filter that in the analog unit is only possible with circuit bending. Using our resonance set screw, you can increase the resonance amount, creating a resonance peak at the cutoff frequency in the low-pass filter. This emphasizes the cutoff frequency, giving you a sound that exaggerates the sweep effect. Even the pure tone component has by default a small amount of click blended in with it. So when playing a pure tone, you'll notice a small click sound blended in at the very beginning of the note, which is also subject to the low-pass filter, controlled by the noise knob. This tone click sound that's embedded in the pure tone component is ultimately slightly different from the pure click sound. We isolated this tone click sound at multiple velocities for each pitch, and we added a set screw control called click defeat that gives you the power to control the volume of the tone click. The click defeat set screw also controls the volume of a separate sample that we refer to as the tone fizz. This is a unique analog distortion in the tone that is generated as a result of the limited headroom in the VCA, or voltage controlled amplifier. The tone fizz is a distinctive analog artifact, and we sampled it for every pitch. It also changes with velocity and moves in concert with the tone click. The volume of the tone click and tone fizz samples are both controlled by the click defeat set screw. You can defeat the tone click and the tone fizz by turning the set screw down for an absolutely pure tone sound. Or you can even push it louder than its default value for more creative possibilities. The tone and bend knobs only apply to the tone component of the sound. The tone knob sets the pitch of the note and ranges 4 octaves from G2 to G6. The bend knob sets the amount of downward pitch bend applied to the tone component. Like the filter sweep, velocity affects the starting point of the pitch bend, as well as the range of pitch bend. So lighter velocity hits push the starting pitch up only minimally, closer to the pitch set by the tone knob, and the pitch bend range is less. Whereas higher velocity or harder hits start the pitch bend higher, and the journey back to the pitch set by the tone knob is greater. In pitch bending, this velocity effect is increased as you increase the bend amount. You should note that when the bend knob is set to minimum, not only is there no pitch bend, but velocity has no impact on the pitch whatsoever. I should point out that the velocity pitch bend effect is somewhat greater for the toms than it is for the bass and snare. In other words, the toms are pitch bendier than the bass and snare when the bend knob is engaged. The decay knob sets the overall length of the note. It ranges from 60 milliseconds to 2.5 seconds. And for cymbals, it extends up to 3.5 seconds. Like the filter sweep and pitch bend parameters, velocity also affects the note length. Lighter velocity hits are slightly shorter, and full velocity hits play the full length of the note. Shortening the note also shortens the bend time for the tone component, as well as the filter sweep time for the noise component. The snare module has two unique features. Firstly, the noise component is different in design from the bass and toms. It's static as opposed to sweeping over the course of the decay. You'll notice that when you increase the resonance set screw, that the resonance peak doesn't move, which is consistent with a cutoff not shaped by the decay envelope. You'll also notice that the click is different than that of the bass and toms. It has a different color and a greater range. The second unique feature of the snare module is that the tone component has a frequency modulation set screw. Adding FM essentially causes the pitch to oscillate at a fixed rate. So you get this slightly indistinct or almost distorted tone the more FM you add. Because the FM frequency is fixed, you really notice how it affects the snare tone when you have some pitch bending. It sort of warbles as the pitch descends. That's because the main snare tone is pitching downward while being pitch modified at a fixed frequency. In the analog realm, you'd have to circuit bend the unit to control the FM amount, but here we've given you the ability to add an extreme amount of FM or completely eliminate it for a pure tone. The hi-hat and cymbal modules share many features with the drum modules, with just a few key differences. The main knobs on the left half of the hi-hat and cymbal modules, the basic mixing controls, are the same: delay and reverb sends, pan and volume. Unlike the drum modules, the hi-hat and cymbal modules do not have a click component, and therefore have no click-to-feet set screw, but instead are comprised of a combination of noise, tone, and bell sounds. The noise tone knob sets the balance between the pure noise and the pure tone sounds. Like the drum modules, the noise sample is not pitched, but the tone samples and their corresponding bell samples are sampled at every pitch. The bell knob sets the amount of pitched bell sample that is blended in with the balance of noise and tone, set by the noise tone knob. The bell sound in the hi-hat module is mixed in with all three hi-hat keys: closed hat, pedal hat, and open hat. These three keys share a single voice and contact, so they will truncate one another. The bell knob in the cymbal modules also sets the amount of bell blended in with the noise tone balance. So with the cymbals, you can have the bell, noise, and tone balance on the main cymbal 1 and 2 keys, C sharp and A2 respectively, but cymbal 1 and 2 also each have a dedicated bell key that is not subject to the bell knob, D sharp and B2 respectively. The main cymbal keys and their corresponding dedicated bell keys do not share a voice and contact, so they will not truncate each other. They will play over the top of one another. The noise knob in the hi-hat and cymbal modules is different from that of the drum modules. The two key differences are, one, that the noise knob is bipolar, meaning that it doesn't just increase one parameter, it sweeps between two opposite extremes with a zero value in the middle. And two, that the low-pass filter in the hi-hat and cymbals applies to both the noise and the tone components, but not the bell component. The bipolar noise knob controls both the amount and direction of the filter sweeping. Turning the knob to the left increases the amount of upward filter sweeping in both the noise and tone components. Turning the knob to the right increases the amount of downward filter sweeping in both the noise and tone components. And setting the noise knob in the middle eliminates any filter sweeping. The filter just stays static. And like the drum modules, velocity impacts the filter sweep. When you add an upward or downward sweep, the harder you hit the key, the greater the filter sweep. Like the drum modules, the hi-hat and cymbal modules have a resonance set screw that adds a resonance peak at the cutoff frequency. So adding a resonance peak can emphasize the filter effect and at extreme settings adds an almost whistling sound at the cutoff frequency. The other key difference between the hi-hat and cymbal modules and the drum modules is that, like the noise knob, the bend knob is also bipolar, meaning it can be set for pitch bending in an upward or downward direction. Turning the knob to the left increases the amount of upward pitch bend. Turning the knob to the right increases the amount of downward pitch bend. And setting the bend knob to the middle sets the amount of pitch bending to 0. And like the drum modules, velocity also impacts the bend amount. When you add an upward or downward bend, the harder you hit the key, the greater the bend amount. Note that the bend knob, unlike the noise knob, only affects the tone component, not the noise or bell components. Although the main tone knob in the hi-hat module sets the general tuning of the tone component in the 3 hi-hat permutations, closed hat, pedal hat, and open hat, the pedal tone set screw can adjust the tuning of the tone component in the closed hat and pedal hat keys only by up to 5 additional half steps up or down, leaving the open hat at the pitch set by the main tone knob. This can help create some distinction between the closed and pedal hats versus the open hat, and add a more natural feel to the hi-hat module. Again, this only affects the tone component of the hi-hat sound, not the noise or bell components. The pedal decay set screw sets the decay amount for the closed and pedal hat keys only. Whereas the main decay knob only controls the decay of the open hat key. Generally, you'd have the main decay knob set longer and the pedal decay set screw set shorter for a standard hi-hat setup. But between the two controls, you have the ability to change those parameters however you want. Each module has a delay send, a reverb send, a pan knob, and a volume knob. The send knobs on the instrument panel correspond to the send knobs in the mixer panel. The pan knobs on the instrument panel correspond to the pan knobs in the mixer, and the volume knob on the instrument panel corresponds to the volume fader in the mixer panel. The far right module contains the target mode button, the presets loader, and basic delay and reverb return controls. When you enter target mode, the Iconic 5 remaps the keys for the last note you hit and lays the full range of pitches across the keyboard. So if you hit the bass key and then turn on target mode, the whole keyboard becomes the bass module, and the full pitch range is available. You'll notice that playing different pitches actually informs the position of the tone knob to reset the tuning. Once you exit target mode by hitting the button again, the tuning stays in that new position. This, of course, only applies to the tone component of each module. This works for any of the modules, and once you enter target mode, the color of the full range of the keys corresponds to the note color of the module you're targeting. So if you hit Tom 3 and go into target mode, the range of keys available turns blue, corresponding to the note color of Tom 3, and you can begin retuning Tom 3 with the keyboard. Note that the tone knob affects the tuning of the tone portion of each module. So if you have the module set for pure noise or pure click, you won't hear any tone, and therefore, there's nothing to tune. The main use for target mode is for setting exact tuning quickly, but there are also other ways you can use target mode. For example, if you reduce the bend knob to 0 and set a longer decay time, you can use a module as a mono bassline synth. Defeating the click for a pure tone works well for this. Or if you, for example, go into target mode on a tom module, you can have 4 octaves worth of tom pitches available at once. Although you should note that in target mode, you would be playing everything from one module, and each module plays one voice at a time. So you won't hear toms cascading or overlapping each other. Each new tom hit will truncate the previous tom hit. The truncating is as if you hit the same tom module over and over again, compared to the cascading or overlapping you would hear when playing tom 1 followed by toms 2 and 3. The Iconic 5 has 10 presets that really capture the range of possibilities for this instrument and feature its era-specific effects setups. You can access presets by using the preset pull-down menu, or you can use the right and left arrow buttons to flip to the next or previous bank. The arrow buttons are CC programmable or control change programmable, meaning they can be assigned to a hardware button on a compatible MIDI controller. So if you're someone who likes to have tactile control, you can assign each of the arrow buttons to hardware controller buttons and flip through presets by hand. You'll notice that the preset name is written in black, but if you adjust any settings at all on the instrument panel or the mixer panel, with the exception of the output busing matrix in the mixer panel, which we'll go over later, the preset name will turn red. The red label indicates that you have now set the Iconic 5 to something other than a built-in factory preset. You should note that if you make changes in preset 1, for example, then you flip to another preset and come back, preset 1 will reload, so your changes will be lost. Every time you load a preset, it loads to its factory settings. The delay return knob sets the return level of the delay effect. The sends set the level that go into the delay effect module, and the return sets the amount of delay that comes back from the effect module. This knob is a quick way to set the global level of delay effect, and it corresponds to the delay fader in the mixer panel. The delay time pull-down menu sets the sync time with your session. So if you have it set to quarter notes, the delay signal will sync to quarter notes in the tempo of your session. The delay time ranges from whole note to 1/256th note. And there's also a millisecond setting for a fixed millisecond value that doesn't sync to your session's tempo. The delay time pull-down corresponds to the delay time pull-down in the actual delay effect module, which you can find in the mixer panel's FX tab. Similarly, the reverb return knob sets the return level of the reverb effect. The sends set the level that go into the reverb effect module, and the return sets the amount that comes back from the reverb effect module. Like the delay return, it's a quick way to set the global level of reverb effect, and it corresponds to the reverb return fader in the mixer panel. The reverb type pull-down menu sets the type of reverb that's engaged, and you can choose from 7 different types of reverb. This pull-down menu corresponds to the reverb type pull-down menu in the actual reverb effect module, which, like the delay effect module, is found in the mixer panel's FX tab. The mixer panel is our console-style mixing environment, and it's accessed by clicking the mixer tab at the bottom of the iconic 5. Directly in the middle are the channel tabs to select which channel's effects controls are visible. The top half displays the selected channel's effects. The bottom half displays the basic mixing controls for all channels. And the far right panel contains the velocity controls and the output busing matrix. Each channel features 3 knobs, delay and reverb send knobs, and a panning knob that mirror the sends and panning knobs for the corresponding module on the instrument panel. Likewise, each channel has a volume fader that mirrors the volume knob for the corresponding module on the instrument panel. And each channel has a mute and solo button, as well as a channel meter. There are identical controls and effects for bass, snare, toms 1 through 3, hi-hat, and cymbals 1 and 2. There is also a mix channel that acts as a drum submix for the whole instrument, a sort of master bus. So if you want to adjust volume or add EQ to the entire instrument at once, or do a global reverb send, rather than just from one module at a time, you can do it from the mix channel. The only parameter that's different in the mix channel is the stereo width knob, which stands in place of the pan knob. This knob sets the overall effectiveness of the pan knobs in the drum and cymbal channels. So if you turn the knob to the far left, it reduces the effect of the pan knobs to 0, making the mix essentially mono. The default setting in the middle makes the stereo image accurately reflect the panning set by the channel pans. And turning the knob to the right exaggerates the stereo image set by the pan knobs. You should note that the stereo width knob does not apply to send effects. Each drum and cymbal channel, as well as the mix channel, which you can access using the channel tabs, has a strip of channel effects: drive, compression, transient master, high and low pass filters, EQ, and tape saturator. To engage or disengage each effect, simply click on the power button next to the effect label. The drive effect has 4 different types of distortion to choose from: tube, op-amp, bit crusher, and transistor, which you can select from the 4-position type knob. And the amount knob simply sets the amount of drive effect for that particular channel. You should note that with the drive effect, even if the amount is set to 0, there is still a small amount of drive that is engaged, and it can alter the sound of that channel very slightly. If you want to have the drive completely off, you should turn the drive power button off. The compressor limiter has standard dynamic shaping features. Threshold sets the level of signal that engages the attenuation. Ratio sets the ratio of reduction once the threshold level is hit. Attack and release knobs set the rate at which the compressor limiter engages and disengages once the threshold is crossed. Makeup gain makes up for the reduced signal strength as a result of the attenuation. And the mix knob sets the overall amount of the effect. You can reduce the mix to back off the compressor limiter for a sort of parallel compression effect. The Transient Master is a really useful tool, particularly for drums. The attack control essentially controls the volume of the first few milliseconds or transient of the signal. So if you want to emphasize the punchiness or hardness of the signal, you can increase the attack setting. Conversely, if you want to soften the signal, reducing the attack will push down the volume of the first few milliseconds and make the body of the note relatively more present, making the signal less aggressive. The sustain controls the volume of the signal after the first few milliseconds, so it affects the body of the signal. Changing the relationship between the attack and sustain, or transient and body of the signal, can greatly alter its character. A low-pass filter is a filter that allows all frequencies below the cutoff frequency to pass through. Low frequencies pass through, hence it's a low-pass filter. And a high-pass filter is a filter that allows all frequencies above the cutoff frequency to pass through. High frequencies pass through, hence it's a high-pass filter. So if you want to darken the signal, you can filter out the high frequencies using the low-pass filter. And if you want to take weight out of the signal, you can remove low-frequency information by rolling up the high-pass filter. The Equaliser is a 4-band British-style EQ. The gray knobs control the low-frequency band. The bottom knob sets the frequency, and the top sets the gain. And the low-frequency bell button switches the low-frequency band from a shelf to a bell shape. The green knobs control the low-mid frequency band. The lower right knob sets the frequency, the top knob sets the gain, and the lower left knob sets the Q or sharpness of the band. Likewise, the blue knobs control the high-mid frequency band, and the controls are the same as the low-mid frequency band: frequency, gain, and Q. And the red knobs control the high-frequency band. The high-frequency controls are the same as the low-frequency controls: frequency, gain, and the bell button switches the high-frequency gain from a shelf to bell shape. The tape saturator emulates the soft compression and distortion of recording to tape. The gain controls the input gain of the effect, which increases the amount of tape distortion and compression, which is distinct from any of the 4 types of drive effects. The warmth is a bipolar knob that can either boost or cut the low frequency of the effect. The Effects Channel tab reveals the Send Effects main controls. Below the tab, you'll see the delay and reverb mute and solo controls, and the delay and reverb volume faders that correspond to the instrument panel effects return knobs. The delay return fader sets the return level of the delay effect. The sends from the drums, cymbal, and/or mix channels set the level that goes into the delay effect module, and the return sets the amount that comes back from the delay effect module. This fader, or its corresponding knob on the instrument panel, is a quick way to set the global level of delay effect. You can use the solo button to preview the delay effect by itself, or you can use the mute button to hear everything without any delay effect. Likewise, the reverb return fader sets the return level of the reverb effect. The sends from the drums, cymbals, and/or mix channels set the level that goes into the reverb effect module, and the return sets the amount that comes back from the reverb effect module. This fader, or its corresponding knob on the instrument panel, is a quick way to set the global level of reverb effect. You can use the solo button to preview the reverb effect by itself, or you can use the mute button to hear everything without any reverb effect. Above the Effects Channel tab on the left are the delay main controls. There are 5 different types of delay effect: modern, analog, tape, vintage, and diffuse. The distortion knob and modulation parameters vary from type to type, but let's go over the parameters that are the same throughout all delay types. The delay time pull-down menu, which corresponds to the same pull-down on the instrument panel, sets the sync time with your session. So if you have it set to quarter notes, the delay signal will sync to quarter notes in the tempo of your session. The delay time ranges from whole note to 1/256th note. There is a millisecond setting for a fixed millisecond value that doesn't sync with your session tempo. When millisecond is engaged, the red LED indicates that the millisecond knob is activated, and the delay time is controlled by this knob. For the moment, let's skip over to the feedback knob. The feedback adjusts the level of signal that is fed back into the delay's input. Increasing the feedback adds delay repeats. Levels above 100% create swelling echo repeats up to self-oscillation. If it gets too wild, just pull the knob down to shorten the delay. The high and low pass filters work exactly the same way as the channel effects high and low pass filters. These controls specifically pertain to the delay signal, not the channel outputs themselves. The ping-pong button is present in all delay types except for diffuse. The ping-pong button causes the delay repeats to alternate between being panned hard left and hard right, rather than all repeats panned center. Jumping to the diffuse delay type, there is a dense button in place of the ping-pong button. The dense button switches between 2 density settings for the reflection pattern of the effect. The difference is more noticeable when the amount knob, which we'll cover momentarily, is set to a higher value. Below the delay type pull-down menu is the distortion parameter. The modern and tape delay types have a saturation knob in this position that sets the amount of saturation applied to the delay signal only. The analog delay type has a BBD type, or Bucket Brigade delay control. This knob selects one of 4 BBD delay models: clean, warm, dark, and grunge. The character, which only applies to the delayed signal, ranges from subtle filtering and distortion to a highly degraded sound. The vintage delay type has a 4-position quality knob. Lower settings make the delayed signal more degraded. In the diffuse delay type, the mod knob sets the depth and speed of modulation applied to the diffusion, shifting the timing and pitch of the reflections for a wide reverb effect. The modulation section is also different between different types of delay. The modern, analog, and vintage delay types have modulation controls depth and rate. The depth adjusts the amount of modulation, and the rate adjusts the speed of modulation. The effect amounts to a sort of pitch warble that applies to only the delay signal. The tape delay type has modulation controls tape age and flutter. The tape age enhances the characteristics of an aging tape, including limited high-frequency response. Flutter refers to the effect of a tape machine's inconsistent playback speed. If you can imagine, tape machines didn't always play back at a perfectly consistent rate, which created a slightly inconsistent pitch warble. The diffuse delay type has modulation controls size and amount. Amount adjusts the amount of diffusion applied to the delay signal, resulting in a reverb effect. Size adjusts the swell, reflection pattern, and decay of the reverb effect, giving the impression of different sized spaces. There are 7 different reverb types: nonlinear 1 and 2, gated, digital, plate 1 and 2, and studio. These impulses were custom made by Numerical Sound and were carefully crafted to capture era-specific pieces of gear and spaces at different settings. Typically, acoustic reverbs like you would hear in an acoustic space decay in linear fashion, meaning the volume drops over time at a steady rate. In the 1980s, recording engineers devised new methods and reverb makers created new technologies to create nonlinear reverbs that had a new and distinct sound. You can imagine a reverb that initially sounds like a signal that's in a large space, but then ends abruptly. This is referred to as nonlinear because the rate of decay doesn't fall off in a straight line. Initially, recording engineers developed a method using gating to abruptly cut the reverb tail from distant room mics. One famous example is the tom sound on Phil Collins' 1981 hit, In the Air Tonight. But digital reverb makers built in gated and nonlinear settings into their gear, and the sound became a hallmark of the era. Preset 3, for example, features our gated reverb, which was created using an acoustic space impulse with a gate to truncate the tail. And preset 6 features our nonlinear 2 reverb, which captures the sound of a particular piece of vintage digital gear's nonlinear setting. The digital, plate 1, and plate 2 impulses capture the unnaturally bright quality of vintage digital and plate reverbs. Unlike the nonlinear and gated reverbs, however, the tails have a natural decay. And finally, the studio impulse captures the sound of a proper acoustic studio space with a slightly darker and more natural acoustic color and a natural decay. The pre-delay knob adds a short delay before the reverb takes effect. This separation from the dry signal can help keep the drums out front without being too immersed in reverb. This knob ranges from 0 to 300 milliseconds. For most situations, 20 to 50 milliseconds works best, although higher values do come in handy when using reverse reverb, which we'll talk about in a minute. The size knob changes to different impulses, which were carefully crafted to capture the quality of shorter and longer reverbs for each different reverb type. The lengths range from 20% to 120% in 20% increments. There's also a reverse reverb option for each reverb type that actually plays a short impulse in reverse for a special effect. There's no way to have the playback sync with your session tempo, so here's where you can use the pre-delay to adjust the timing of the reverse reverb. If you have the pre-delay set too short, it'll just crowd the dry signal. But if you extend the pre-delay to time it so that the reverb hits at 1/16 or 1/8 notes in relation to your track's tempo, it can make a really unique effect. And finally, the high and low pass reverb filters perform the same way as the channel effects high pass and low pass filters, but only affect the reverb itself. The high pass filter can take some weight out of the reverb effect, and conversely, the low pass filter can make it sound darker. The velocity control has two modes, velocity curve mode and fixed velocity mode, that you can toggle between by clicking on the label. Velocity curve mode takes the incoming MIDI from your controller and remaps the velocity along a curve set by this knob. It's a way to adjust the touch and feel of the Iconic 5 in relation to your MIDI controller. If the knob is set to its default setting, in the middle, the velocity interpolation is linear. In other words, it doesn't remap the velocity from the incoming MIDI at all. The standard MIDI velocity range is 1 to 127. So if you hit a light note, say a velocity value of 25, it passes that straight through to the Iconic 5 as a note with a velocity of 25. Likewise, if you hit a high velocity note, say a note with a velocity of 120, it passes that straight through to the Iconic 5 as a note with a velocity of 120. If you turn the knob to the left, it will reinterpolate the velocity of your performance along a concave curve. So now your light note with a velocity of 25 might trigger a note with something like a velocity of 20, and your high velocity note of 120 might trigger a note with something like a velocity of 115. The overall effect of turning the knob leftward is that only the hardest hits on your controller will trigger loud notes. Conversely, turning the knob to the right will reinterpolate the velocity of your performance along a convex curve. So now, your light note with a velocity of 25 might trigger a note with something like a velocity of 30, and your high velocity note of 120 might trigger a note with something like a velocity of 125. The overall effect of turning the knob toward the right is that even lighter hits on your controller will trigger loud notes. Even though this knob can go to extremes, it's really meant to make modest adjustments to match the touch of whatever controller you're using. Fixed velocity mode will remap the velocity of the notes you're hitting on your controller to the value set by this knob. So if you have the knob set to the middle value of 64, no matter how hard or light you hit your controller, the Iconic 5 will trigger a note with a velocity of 64. And if you have it set to 127, no matter how hard or light you hit your controller, the Iconic 5 will trigger a note with a velocity of 127. This is useful if you want a very even performance, or if you want to preview a note with a very particular velocity. Finally, this section is the output busing matrix. The channel outputs for each drum and cymbal can be directed to alternative outputs and then into individual tracks in your DAW. Having individual drum or cymbal tracks just allows you to mix your Iconic 5 in your DAW environment rather than within the Iconic 5 itself. We'll go through how to set up the contact outputs and how to direct the channel outputs of the Iconic 5 using the output busing matrix. But you should note that each individual DAW, Logic, Pro Tools, Ableton, Reaper, etc., has its own way of breaking contacts outputs into multiple audio or auxiliary tracks. So we'll put some links below in the description of this video to other videos that show you how to direct contacts outputs to individual tracks in your particular DAW. The very first thing you have to do if you want to route multiple outputs is to load a multi-output instance of Contact. If you just choose stereo from your Contact plugin menu, routing multiple outputs won't work. Let's load a multi-output instance of Contact. The first step is to load a software instrument track. This will be a slightly different process in different DAWs. From the plugins list, navigate to Native Instruments, Contact. I recommend selecting the multi-output 16 times stereo version because it's more than enough outputs, and using stereo outs will reflect the stereo send effects and will retain any panning you've done in each channel of the Iconic 5. Now in the Contact window, let's load up the Iconic 5. We'll use preset 1 to demonstrate. There are up to 64 discrete outputs available in the Iconic 5, but you first have to set up the outputs you want to use in Contact for them to be available from the output busing matrix. If you click on Contact's Workspace menu and select Outputs, you can see what outputs are currently set up. This is one of the standard default output setups in Contact. There are 2 stereo outputs, 1 surround 5.1 output, and 4 auxiliary outputs. You should note that Contact's auxiliary outputs will not appear as available in the Output Busing Matrix pull-down menu. Let's look at the outputs available to us in the Output Busing Matrix. There are 4 options currently available: Default, Output 1, output 2, and output 3. If we want discrete outputs for each drum and cymbal module, we have to change Kontact's output setup. So how do we change the available Kontakt outputs? The easiest way to set up multiple outputs at once is to hit the plus button in the top of Kontakt's output window, and this dialog will appear. The Iconic 5 has 8 drum and cymbal channels that can be routed using the output busing matrix, but I recommend setting up 9 outputs. I'll explain why later when we talk about send effects and routing. For number of channels, you should keep a value of 2 to create 9 stereo outputs. For standard host output, you must make a selection here, so you can just select ST1 from the pull-down menu. Leave the ascending output assignment radio button checked. In this case, we do want to remove the current output setup, so I will check the delete existing channels before creating new ones radio button. Note that if you decide to add more outputs, don't check this box unless you want to delete the outputs that are already set up. And finally, regarding the Make This Your Default Configuration radio button, I presume you'll not want this setup to be the default output setup going forward, since you probably use other instruments that don't need the same configuration, so I would not check this box. Hit OK and you'll see 9 new stereo outputs pop up. You may or may not see a message pop up telling you that you have to reinstantiate Kontakt to see the changes. If you do see that notice, just hit OK and we'll go through how to avoid restarting Kontakt. Now, if we go to the output busing matrix, you'll notice that although we just set up 9 stereo outputs, there are still the same 4 choices from before. Instead of restarting Kontakt, just go up to the restart button, represented by an exclamation point, next to the system performance meters. This will restart the Iconic 5 and update the pull-down menu to correctly reflect the number of outputs. I've gone ahead and set up multiple tracks in Logic to receive the individual outputs from Kontakt. As stated earlier, each DAW will have its own process for setting this up, so we'll put links in the description of this video to help you through those steps in your particular DAW. But now that you have Kontakt's output set up, you should think of this in 2 stages. Use the Iconic 5's output busing matrix to assign each drum or cymbal's channel to its own Kontakt output. Then the signal flows from Kontakt's outputs into the individual tracks in your DAW. Now here's where it gets a little confusing, but this explains why we set up 9 outputs for the 8 drum and cymbal channels. The Iconic 5's send effects, the delay and convolution reverb, are only routed to Kontakt's Stereo 1 output and cannot be directed elsewhere. So let's exaggerate the reverb in the bass channel to demonstrate how the signal flows. If we assign the bass channel to the default output, we hear and see the bass and reverb going into Kontakt's Stereo 1 output. And we can also see and hear it in the first track in Logic that we set up. The Iconic 5's output 1 also goes to Kontakt's Stereo 1 output, so anything assigned to output 1 will also be blended in with the send effects. But if we assign the bass to output 2, we'll see and hear the send effects in Kontakt's Stereo 1 output and the dry bass signal in Kontakt's Stereo 2 output, which we can see and hear reflected in Logic as well. I can solo the tracks in Logic to hear the send effects in the first track and the dry bass in the second track. The best practice is to leave the default /output 1 for the send effects only, so that you can print the dry stems separately from the Iconic 5's built-in send effects. You can keep them separate from the send effects by assigning your drum and cymbal modules to outputs 2 through 9. Feel free to drop us a line at info@iconic.nyc if you have any questions or comments. We'd love to hear from you. Thanks for checking out Iconic Instruments.